So here I've been given the tan ratio as -5/4. So slope is -5/4. So maybe it's going to cut through something like that. So it's got my negative slope. So I'm in, here's -4, +5. Here the slope is going to be +4, -5. Okay, so those are the positioning of those 2 points. So there are 2 different locations I have to consider. Now it says it's in quadrant 4, so I only need to worry about this one position. So I'm just going to highlight that it's only this position that we're really concerned with. Okay, so that's quadrant 4. So when I solve for this, actually first of all it says find the exact values of sine, cos, and tan. Okay, I know that it's in quadrant 4, so I don't need to worry about the quadrant 2 angle. So I'm going to solve for my triangle here. We're going to solve for my radius. So 5 squared plus 4 squared is going to be 41. So my radius is square root 41. And because I don't have to worry about this other angle in here, I'm going to just give one value for sine, one value for cos. Okay, so sine theta is going to be -5 over square root 41 because it's in quadrant 4. Cosine value is going to be +4 over square root 41 because it's in quadrant 4. Okay, if we didn't know the quadrant, there are 2 possible cosine values that we'd have to consider. So the reference angle here, we'll have to first find out the standard position angle. So we can use sine, cos, or tan to work out that ratio. So here, since we're given the tan, I'm going to use the arctan, and the input is going to be the ratio, the output is going to be the angle. Okay, so that's going to be θ1. So I'm going to do second tan of -5/4. That gives me -51.34 degrees. Okay, so I have to ask myself, is this in the right position? Is -51.34 degrees in quadrant 4, or is it the other angle here? And in this case, this is the correct angle. Okay, so that's the right position. Now I want to get in the habit of putting this into positive values. So my positive value is going to be 308 degrees, 0.66. 308.66 degrees. So these are equivalent positions. One is just the positive version of the other. So these are the same. Okay, these are both θ1. Now, we weren't asked for θ2, but we really should figure out what θ2 is and how to find it. So θ2 is on the other side of the circle. Okay, so I'm going to do this in a different color. So θ2 is over there. So θ2, I'm just going to either add or subtract 180 degrees from that angle. Okay, so adding 180 degrees just puts it on the opposite side of the circle where that slope would be. So this is going to be 128.66 degrees. And that's my θ2 position. And that's the wrong one. That's not the one I want, because I want the quadrant 4. So I'm just going to make sure I highlight that. These are both quadrant 4 angles. That θ2 is not. The last thing here, it asks for the reference angle. The reference angle then would be the angle in the triangle here. And that's going to be 51.34 degrees. Now really the reference angle is useful to give shape, but really we want to make sure we're focusing on the position. It's in quadrant 4. That's very important, because if we just say 51.34 degrees, that implies it's in quadrant 1. So this one here, we've been given the cosine, and again the quadrant is known. Okay, so since the quadrant is known, although the cosine can be in 2 different positions, we're only going to consider the ones that end up here. Okay, so it says find the reference angle and the standard position angle. So I want to undo this cosine, and again the input is a ratio. I never put ratio into the cosine. I put the ratio into the inverse cosine, and that's going to give me theta 1. Okay, so theta 1, when I work this out, so I do inverse cosine of negative 3 over 5, and I get 126.87 degrees. Okay, so that's somewhere around here. That looks about right because it's going to be negative 3, positive 5. Oops, so positive 5 is going to be along the radius, and that's going to be 126.87 degrees, which perfectly consistent with what we've been given. The problem is that's not the right quadrant. So how am I going to find the right position? Okay, so first things first, I'm going to just find the reference angle here. So I'm going to subtract that from 180. So my reference angle in here, that angle works out to be 53.13 degrees. Okay, so that's my reference angle. I need to really make sure I find the right position though. Okay, to find the right position, I've got to use a symmetry for cosine. The symmetry for cosine is folding across that horizontal line, and I know that's going to be negative 3, 5, and the angle in here is going to be 53.15. So I could use my reference angle and add it to 180. I'm going to do it slightly differently, and there's a formula for this, so I'm going to just use a formula. 360 degrees minus, because of the symmetry going in this direction, I'm going to minus 126.87 degrees. Okay, so when I do that, I end up with 233.13 degrees, and that is in the right quadrant. So 233.13 degrees in quadrant 3. So that is a correct. I'm just going to get rid of this line here. Okay. That is a correct standard position angle. So that angle is in the right position in quadrant 3. And again, the position is the most important thing. We're locating position when we use this angle. So there it is. So the x and y coordinates said define the circle in radius 5. I'm going to answer that first because this is radius 5. So if I use if I use Pythagoras, I get 5 squared minus 3 squared equals 4 squared. Now the position is negative 4, so it's very important that we keep track of that negative. So it's going to be negative 3, negative 4. It also asks, what's the position on the circle of radius 1? Well, circle radius 1 means that the cosine value is my x value, my x coordinate, my x position. So negative 3 over 5 is my position on a radius 1 circle. The cosine value becomes my position. The sine value becomes my y position. So my sine value is going to be negative 4 over 5. So in a radius 1 circle, it's going to be that point right there. What we could do is also just scale this down from radius 5 to radius 1, use proportioning, and make these two coordinates 5 times smaller, and we get those points as well. But it is good to understand the unit circle, that the unit circle allows us to use the cosine ratio and the sine ratio as actual lengths and position, and that's very convenient for to be able to do some more math on that.